Hello and welcome to this LangChain tutorial. So in this video, we'll discuss what are text splitters in LangChain and then we'll go through some of the available text splitters with code examples. So as we saw in the previous video about document loaders in LangChain, right? So when you are creating a RAG pipeline, first step is to load the data and split it. So the documents you load using document loader, right? They may be very large in size. So when you are sending data and query both to the LLM and want the LLM to form its answer to the query based on the data you are sending, then sending the whole document as your data is quite impractical. So if you are creating RAG pipeline where you are sending the data plus query both, then you don't want to send your whole document as the data. So as a first step toward managing the loaded document, you can use text splitters in LangChain, which can break the large document into smaller manageable chunks. So you can send only some of those splits, some of those relevant chunks to the LLM as data. That will help your LLM to process it more efficiently without losing context. Okay, so coming up to some of the reasons why you'll need a text splitter actually. So first is context window limit. So LLMs have a maximum token limit. So if you are trying to send an entire book or a very long document with your query, that will exceed this limit and fail. So if you split that loaded document into smaller semantically coherent chunks, then you can send only the relevant chunks. As per your query, you can send only those chunks that make sense for that particular query to the LLM, right? Instead of the entire document. So that way you will be in that context limit. So here I would like to add one more thing, that with newer versions of LLMs like with GPT-5 or Claude, LLMs now have massive context windows actually, 100,000 to up to million plus tokens. So you may think, okay, now anyway, my whole document will fit within the context window. So why bother about the splitting, right? So just to set that expectation, with 1 million tokens, right? You can send, I guess, 2 MB to 4 MB of raw text. That will be equivalent to that much. 1 million token is equivalent to 2 MB to 4 MB of raw text. So you might have even come across some articles or videos claiming that how long context windows have killed RAG. But you have to keep in mind that LLMs charge by token usage. So if you are sending lots of data, that also means higher costs, right? As well as the time taken to process this whole document to answer your query. It has to go through whole data to see what are the relevant portions as per your query. So that means increased latency also. That brings us to the second point, which is about token efficiency only. So if you send the entire document without any splitting, then LLM has to process every token, even irrelevant ones. That obviously means more cost and also slow response time. With this combination of splitting and retrieval, only the relevant chunks are injected into the prompt. This means fewer tokens are consumed and your overall cost is lower. So for example, suppose you want to create a bot that answers question for the insurance policies and you have loaded document about all the policy rules. And then if user query is about the waiting period for pre-existing diseases in medical insurance, then ideally you should only send the relevant chunks, right? Rather than all the policy rules. So you should send chunks that contain information about that asked question. What is the waiting period for pre-existing diseases? Rather than all the policy rules. So that's what you mean by sending the relevant chunks and what you mean by token efficiency. So here again, I would like to tell about this term token a little. So LLMs understand and process information strictly in terms of tokens. The prompt you write is first broken down to words, subwords, means part of word, or even character. That depends on the algorithm used by the LLM. So one of the algorithms that comes to mind is byte pair encoding, which is used by GPT model. So as per the algorithm used, they'll first break your whole sentence into smaller words. Then these words are also converted into numerical IDs actually. So these numerical IDs actually are the tokens which are sent to the LLMs. So just to let you know what you mean by token. Then the third benefit you get by using splitting is you have efficient retrieval in RAG pipelines. When you are creating a RAG pipeline, one of the steps is to store this loaded document into the vector database so you can later do similarity search. If you split document into smaller chunks and store those chunks, not the whole document as is, that will improve your search efficiency and ensure that relevant chunks are retrieved from the vector DB. So when user asks a query, right, then first you look for those chunks in the vector DB which are similar to the asked query. Then you send those relevant chunks and your query to the LLM to form the final answer. That is the flow of RAG actually. If it is not making much sense right now, no problem. We'll cover all the building blocks of RAG in detail, so it will start making sense. Then there is also one benefit, maintaining semantic coherence. So I'll talk about it in one of the splitters. There I'll talk about it. Okay, so with that, we come to the available text splitters in LangChain, and one of the first one which we are going to discuss is CharacterTextSplitter, which is one of the simplest text splitting utilities in LangChain. And for separator, actually, it uses the /n/n, which is paragraph. So for split points, right? What will be the separator? How will it identify the split points? For that, it uses /n/n, which is paragraph. And chunk length, it will determine by the number of characters. So for that, there is a parameter actually within CharacterTextSplitter, that is chunk underscore size. So using that, you will give the number of characters which will be there in each split. So it will follow that to create splits of that many characters. But here, one thing you have to notice is that each chunk will contain up to 1000 characters. It doesn't mean like hard rule that it has to have 1000 characters. That is one benefit of these splitters, that it tries to look for a natural boundary, right, which is paragraph in this case, or section also. So tries to um, avoid breaking mid paragraph or mid sentence, which is like breaking mid thought. So generally that happens, right, in a document. You have one paragraph for one topic, then for another topic, you move to another paragraph. So it tries to honor that, to maintain the semantic meanings. So even if you have given chunk size as 1000, let's say, but your paragraph ends at 900 character count, so it will create split of that 900 characters only, won't try to fill all the 1000 characters. So that's what you mean by that, maintaining semantic coherence. So that is also one thing with splitters in LangChain, that it still tries to maintain that semantic meaning and does not go by that chunk size as a hard rule that, okay, I have to create a split of that many characters. All right. So character splitter, if you see when you are creating an instance of CharacterTextSplitter, these are the things you will pass. Separator, we have already discussed. Chunk size, you know. There is also a chunk overlap. So that is also one, you can say, functionality given by the splitters in LangChain, that you give some overlap so that one split to another split, right? There is some mapping, you can say, right? Or it is easy for your semantic search. When you do, it is easy to understand, okay, this is the continuation of the previous split. So you have some overlap also. That means some part of the, where your paragraph, where your split ends, right, one of the split ends, that some of the characters will be the starting point of the another split. So you have that kind of mapping also. that okay, this split and this split have this mapping. That means it is the continuation of the previous split. So that also helps with preserving the semantic meaning. Then you also have a length function, which is actually the way it determines if you give some chunk size, right? How will it know? So it uses this length function to determine, okay, this is the length of chunk size. And for that, by default, it uses the standard Python len function. All right. So once you have this instance of character text splitter, on that you can call one of these methods. So split text you can use if you have raw string only, then you can split it using split text. Or if you have already used a document loader to load your document and now it is in form of document objects, then you can use split document to split that. So these two methods are there. With that, let's try to create an example of a character text splitter. So if I go to my IDE, I have already created one folder L6. In that, I'll create a new file. Let's name it TextSm.py. Okay, so here, so this is the character text splitter, which is imported from LangChain underscore text underscore splitters. And this is the text I'll use to split. So first thing, you have to create a instance, and let's name it that instance as text underscore splitter. So in that you can give chunk size since it's not lot of text, so I'll give 100 only, and chunk overlap as 20. Then separator, again I'll just change it to new line, space, not new line, space, because we don't have much text here. So if I give, by default, if I take that paragraph only, mostly it will go in one chunk only. So now I have my text splitter. So what I have to get is, let's say I name it chunks. So text underscore splitter. Since it is raw text, so I will use the split underscore text method and have to split text. Is text only, okay? So that's how I can get chunks. Then I may write some print chunks or created chunks number of chunks I can take as len chunks, right? And if I want to go through these chunks, I can iterate through that list. So I can take some index also for I chunk in, then I have to use enumerate on these chunks. Right, so I'll use this as my loop where I can go through these chunks. Then I can again do sprint. What I want is an index. So let's say chunk I plus 1 and then actual content. So I'll use chunk. And I will also use slash n. So there is some line after one chunk is printed. All right, so that is what we have. So importing, then some text. Main thing is how you create an instance. So chunk size, chunk overlap, separator. Then you split it, then just some printing. With that, first thing I have to be in my virtual environment. Okay, so here I can run it on slash, where am I, L6 splitters. Within that there is only one class. All right, so these are my splits. Created number of chunks is 7, so it has given me 7 chunks. And if you see, as text returns here as text in the starting of next chunk because of that chunk overlap. Here also, if you see, unlike traditional, here also unlike traditional. So you have some overlap also. Trend on massive, trend on massive. And if you see, not all of them are of equal size, right? That is also quite obvious. Otherwise, all prints will be of same size. That means it is trying to keep split at least, that you can see, right? It is not going anywhere in mid sentence or mid word, right? It is keeping at least whole word intact. You won't find anywhere that your word, that okay, 100 chunk size and set, let's say, prompted in that at a PROM only. So it is not giving you like that, that when prom and another one starts as head. You're not getting like that, right? So that is about one of the splitter, character text splitter, which you can use. And we have gone through all the things also, which we can see here, that it tries to maintain that semantic coherence, and what are what all parameters you can use, what they mean, you can see also here. So next text splitter class in the list is recursive character text splitter. So this is one of the most used text splitter in LangChain for generic text. So what happens is, with recursive character text splitter, you have a list of separator rather than a single separator. So default list of separator goes like this. First element in the list is slash n slash n. So first it will use paragraph to split. Then you have slash n, which is single new line. Then you have space. Then you have empty string for individual characters. So it will go through this list of separators. So how actually recursive character text splitter works is, it will first use the first separator and take that chunk size, whatever is the chunk size. So it will try to split your whole document as per the given chunk size and using the first separator. Then it will recursively check all the splits or chunks in your splits. If any of the splits is exceeding the chunk size, if yes, then it will go through the next separator in the list and use that to split that particular chunk to bring it to within the chunk size limit. And then it will follow this process with other separators also. That is why the name, because it recursively does the same thing with all the separators to bring your whole document within the chunk size limits and split it completely, right? So that is why the name recursive character text splitter. Okay, so as an example for this, we'll try to do the whole thing where we load the document and also split it. So I'll go here again and create a new file, recursive split demo. Okay, and these are my imports. So I need recursive character text splitter to split. I have also imported PyPDF loader because I want to load also that document. And I will join to create a path because I kept the document, which will be this PDF, in resources. So my first function will be get file path. So it will try to get the file path for the given file name. So for that, I can use this OS module. So first thing, I have to get the directory where my code is running. So os.path dot name. Within that, I can use os.path to get the absolute path for the current file. That for that I can use this. Then from that I have to go one level up, because this resources is one level up, right now I've come to this level where my current code is running. So it is in this folder, right? TextSplitter. I have to go to one level up. For that I can use again the same thing, os.path.name. Within that I can pass this to get the directory for this. Now I have the parent directory. So I can create my file name. Let's call it file path, full path, os.path.join. So within this directory, then I have to add the directory where my file is residing, and then the file name. So I'll take this name. All right. So this is my file name. Let me spider wrap also. So that is how I can get my full path. Then I'll return this file path. So this is first. Then I have to load documents. So the load underscore document, where I'll get what file name. Correct. I'll get this file name. So using that, first I will call this method to get the correct path for the file. Then I can use PyPDF loader to load it. So PyPDF loader, where I can pass this file path. That will be my loader. Then I can get the documents by calling the load method on that. So loader dot load, that will load the document. So now I have the document which I can return. Documents. Want to check, we can put a print also here, that length of documents. How many documents are there? We can check with this using length of documents. Correct. So this is my second function which will load. Now the third thing, where I will split it. That will pass here. You know that PDF is having 41 pages, so that means it will create one per page. So I'll have 41 documents. So now I can use split document, where first thing I have to create a instance of this RecursiveTextSplitter, where I can pass chunk underscore size. With this I can give a bigger one, because there is a lot of text in that PDF, and chunk under. So actually you should give a bigger size, 1000 to 2000 as chunk size, and chunk overlap also 200 to 300 range. I can give 200 here. So that will be my text underscore splitter. So now I have the splitter ready. Now I have to call the since we are loading documents, so I can call the split document. So chunks equal to splitter dot load underscore documents. Not load, right? Split documents. I'm splitting it. So split underscore documents, where I will pass this documents. All right. So using that, it will split it. Now I have the. So if I want to check, I can again put length of chunks, where I can do length of chunks. And if I want to check individually, then I can use in chunk in enumerate chunks. So there will be a lot of chunks actually. So rather than going through all of them, let's keep it to 3. So that for first 3 it will print I chunk in enumerate chunks 3. Then I can give here put it here, length of chunk. So that will give me character count actually. Split char count, which will be length of chunk. So that will give me, this will give me character count actually, how many characters are there. So chunk will, something is missing, right? I have to use page underscore content because I want the character count. Then if I want to print the, and I should also give for which chunk. Oh, not this, I plus 1 chunk. All right. Okay. Should be. Print of I think I'm doing wrong. What is that? Viable here and here. Then I can take this part from here itself. Lot of data. Then if I want the content, so chunk I plus 1 content, if I want, then I can use this whole thing. Chunk dot page underscore content will give me the content. After that, let's use slash n also. Here also I can slash n. All right, so this will give me the content. Same way I can get the metadata of each document using metadata. So chunk dot metadata will give me the metadata for each chunk. So let's change it to metadata. So metadata content. All right, so this is my code for RecursiveTextSplitter, where I'm trying to do all the steps, load the document and then split it, and doing it in proper functions. So one function which give me the file path, then to load the document. So file path, then load document by PDF loader, load it. Then you take these documents, then I can run it if So first I have to call this one documents. I'll get from this load underscore document with my file name I've given here. Should have kept it here. Right, and here I should give file name. Whichever file I pass here, that will be loaded. Then using that, I can call this split underscore document. Just need these documents. Printing there itself, so I won't get any, no point in getting any return. So that is what I have for this. I'm already in my virtual environment, so I can try to run it and let's see if there is any error. Recursive demo. Okay, so I've got it. So a lot of data. So length of document is 41, length of chunks is 139. So from that it has got the 139 splits from 41 documents. For chunk 1, length is 914 characters. Content it has given. Then we have chunk 3. I've come to chunk 3, which is 983. So though I've given 1000, but if you see character count is either 983 or what was that, 913 here in chunk 2, and in first one it was 914. And you have some metadata also. So associated metadata also it will keep for each chunk. All right, so this is about recursive character text splitter. Okay, so another one in the line is code text splitter. So there are specific classes in LangChain actually for code splitting, like Python code text splitter class is there for Python. But actually the recommended approach as per LangChain also is to use this recursive character text splitter itself. In that you have a method called from underscore language method. Using that you can split code. For that there is a enum also. Using that you can specify the language which you want to use. So name of the enum is language itself, which is in LangChain underscore text underscore splitters. With that, you can pass the language for which you want to split the code. So it will instantiate the splitter as per that particular language. So let's quickly do that. I'll just quickly show you one example. Don't want to spend a lot of time on this one. Okay, so you get recursive character text splitter, and this is the enum language. Then I have some Python code, and then I create a recursive character text splitter instance using from underscore language method. There you can pass which language. So I've chosen Python only. Chunk size, since it is a very small code, and no overlap. So with the code splitting, right, it will try to honor the function or method boundaries. So one function or method within one split rather than splitting it between two splits, right? So that is the idea about code text splitter. And if you see here, I've used create underscore documents. So that is another method given in splitter, which will do both the jobs. First, it will convert the raw text into document objects and then split it. So both things will be done by this method itself, create underscore documents. With that, let's try to run it. Recursive, not recursive, it is code text split demo. So if you see, it has created Python docs. So two documents and two splits also for that. So one is this page content is this for one split, and another split is having this split. So as you can see, two functions, I mean, you have one function and call of that function. So those are created in separate splits. So that's how you can use CodeTextSplitter to split the code. So next splitter class we are going to discuss is TokenTextSplitter. So I already talked about tokens in the beginning, that whatever prompt you give is converted into tokens, as LLM understands only tokens, and they have some token limit also. So if you want to ensure that your prompt follow that token limit, then you can use TokenTextSplitter, because let's say you are giving a prompt of 10 words, but you don't know how many tokens will be created for that particular prompt. It may be 10 only, or maybe 20, or maybe 100, depending on how LLM is converting into tokens. So that is the idea of TokenTextSplitter, and you will use it if you want to be mindful of your context window, or you want to ensure that you send your prompt within some given token limit. So all that you can do with TokenTextSplitter. So how it works is, actually, first thing, you will convert your text into tokens using some encoding. So you can pass some encoding algorithm also with your splitter. Then it will do the splitting by that token count. So chunk size which you give. So initial classes which we use, right? CharacterTextSplitter or RecursiveTextSplitter. There it meant count of character, but here chunk size means count of tokens. So using that chunk size, it will create splits of that many tokens in that particular split, right? And the overlap also is applied at the token level. Then it will convert tokens back to the raw string. So that also it will do, actually. So you can see the work involved. So it is a little slower than other splitter, but you will be pretty sure about your token limit, or how many tokens you are sending. So that is the idea about using TokenTextSplitter. So if we have to create an example of this TokenTextSplitter, then what we can do is, in TextSplitter itself, I'll create a new file for token split demo.py, and in that I will get this much data already. So what I am getting is TokenTextSplitter import from LangChain underscore text underscore splitters, and some text which I'm going to split. Then of course you have to create an instance of TokenTextSplitter, which I'll call text underscore splitter. So here, as I said, you can pass encoding also. So encoding, let's say I use there is one CL100K underscore base, which is for actually used by these GPT models. So encoding, I think it is encoding underscore name, not encoding itself. Other two are same. Chunk underscore size, don't have much text here, so I'm using 100, and chunk underscore overlap I'll keep as 20. So this is my text splitter. Then using that I can create chunks. Is the variable I'm using. How I can create is using split underscore text. I'll use here. Name is text itself, so I'll pass that text. Now I have my chunks also, correct? So split is also done after creating the instance. Then it is same, so I have to do the print. So in char, what we did, I can take the same thing and put it here. Created number of chunk I'm getting, then I'm printing the chunks. So that is what we can do with TokenTextSplitter. New thing is I'm passing the encoding name also. Using that, it will tokenize the document which I have. I have text here itself. All right, so that is all. Then I can run it. Python dot slash L6 within the token split demo dot. So first it will convert this into token, and it will use this chunk size also. So 100 tokens in each split it will create, right? So splits with that. As you can see, it was a little slow, right? Because it is doing all that work of converting it to tokens, then splitting it, and then converting it back to string. So it has created two chunks, chunk 1 and chunk 2. If you remember what we did with char text splitter, there we were using a separator as a space. And if you see, same thing is here, same text, but now it is token text splitter with 100 tokens. So you can see it is a little different. If you want to go back, rewind and check, there were, I guess, 7 chunks with that particular example, and here there are only 2. All right, so this is about token text splitter. Then if we go back to other splitters, so there are many more. So there is actually in LangChain there are many more splitters. I'm just telling about some of them. So for JSON also there is recursive JSON splitter, like we have for text. Then there is also for markdown text splitter if you have .md file. Then for HTML also, so if you have HTML code which you want to split, it gives specific splitting classes also. So if you want to split based on header text, then you can use HTML header text splitter. Based on section, then you can use HTML section splitter, or HTML semantic preserving splitter, so that it will create chunks while keeping in mind the semantic structure of the elements. So one paragraph, it will keep the whole paragraph, right? Tag P, then slash P, where it ends, if you know HTML. So it will try to keep that whole paragraph into one split, or if you have list ULLI, right? Then it will try to keep that whole list into one particular split. So this is about text splitting, which is again a very important step in learning about RAG. So we have done document loader and split. So data ingestion part is done, but there are many more steps. So we'll go through all of that. Thanks for watching the video. Please don't forget to like and subscribe.